This video is over lesson 61, area of a parallelogram, angles of a parallelogram. So ladies and gentlemen, if you have not yet watched the TED Ed video on flat land, please stop this video and go watch that first. It is going to give you some visuals and go over some ideas of things that I would have talked about you if we were in class together. But since we're here on the video, we're going to kind of use that to help us out a little bit. So one of the things that hopefully you caught in the course of the video is this idea that if we move in one direction, one dimension, we get a length. If we move in a completely new direction, we're going to have to move at a right angle, and that's where the visual gave you that square, and so we get something that's two-dimensional. And then if you move in a completely new dimension from that, you got to move it at another right angle, but this time to both of the previous two directions, and we get a three-dimensional figure. So when it comes to finding these new measurements as we move to higher dimensions, so with one dimension we just have a length. With two dimensions, though, we get this new measurement we call area. So we need two lengths that make a right angle to get this new measurement of area. When we move on to three dimensions, we get this new measurement called volume. And now we need three measurements that all make right angles with each other to find volume. So it's this idea of a right angle as we move on to higher dimensional things is super important. So let's dive into our lesson here now. In order to move in a completely new direction, or new dimension, we must move at a right angle to all previous directions. Area, being a two-dimensional measurement, must be calculated using two measures that are at right angles to each other. So I'd like you to please grab your yellow highlighter here, okay, and highlight area must be calculated using two measures that are at right angles to each other. That's super important. We see this clearly when finding the area of a rectangle. Since the sides of a rectangle make right angles, we simply multiply the length by the width to find the area. So there's a length, there's another length, there's a width, there's a width. They make right angles. Those are all right angles. I don't have them marked, but they are right angles. And so the area then is length times width. A equals LW. So moving on to kind of the point of today, if we're looking for the area of a parallelogram, rectangles are just special parallelograms that have sides that make right angles, whereas parallelograms don't have to make right angles. However, there are many parallelograms where this is not the case. To find the area of a parallelogram, though, we still need two measures that make a right angle. So at this point, I'd like you to grab your orange, and let's highlight this last sentence. We need two measures that make a right angle. So in a parallelogram, like this guy here, you'll notice that the bottom and top have been labeled with B. B there stands for base. It does not stand for bottom, it stands for base. Okay. Often, this side right here is just labeled side. And notice he doesn't get used because I need a right angle. And since this side does not make a right angle with the base, we actually use this measurement right here. We use what we call the height. So, and it's got to make the right angles. There's my right angle symbols. Or sometimes it can be shown outside of the figure. We use dashed lines outside here. Okay. So this height is actually not one of the sides of my parallelogram, but it's a measurement inside of or alongside of the parallelogram that makes a right angle with both bases. And that, ladies and gentlemen, is key. So if we move on to looking at an example here, so here's my parallelogram. So if I want to find the area of this parallelogram, I'm going to use the formula that we just talked about. So remember that A equals BH, base times height. A equals BH. So we don't know what the area is yet. We want to solve for that. So in my homework, I'm going to write A. We're going to copy the equals down. Next in the formula is B. B stands for base. So we're looking for the right angle. The base will be making a right angle, and it will be one of the sides of the parallelogram. So notice here that there's a right angle right there. 12 is one of the sides. Or there's a right angle here, and 12 is one of the sides. Now the 10 does come out from here, but notice where this little square touches. It touches this, and it touches that. So the 10 is not part of the right angle there. So it's got to be the 12. So 12 yards, don't forget your units, please. That's my base. Well, BH, of course, means base times height. And so the height is going to be whatever makes that right angle with that base. So going from base to base, I have 8 yards. And so if we go ahead and do what this says now, A must equal 12 times 8 is 96, and yards times yards, now since this is yards times yards, they're going in 2 dimensions, square yards. So 96 square yards. That is the area of my parallelogram. Let's go ahead and flip to the next side. So over here I've given you a little bit of a grid. And so what I'd like you to do is I'd like you to start in the top corner and then come down 3 spaces and just make a little tiny mark there. Just a little tiny mark. Come down 3 spaces, make a little tiny mark. And then what we're going to do is we're going to come over 1, 2, 3, 4 spaces and move up 3. And then I'm going to connect these 2 dots here. Now, from each of those dots, I'd like you to draw a segment that is 6 spaces long. So 6 spaces long, and then 1, 2, 3, 4, 5, 6 spaces long there. And then I'm just going to take these 2 ends and connect them. And there's my first parallelogram. So ladies and gentlemen, if we want to find the area of this parallelogram, we just made this 6 units long. I also know that this is 6 units long. Using some techniques that we have not learned about, I can tell you right now that this side right here is 5 units long, and this side right there is 5 units long. So let's find the area. Area, let's actually start with our red pen there. So, sorry guys, give me just 1 second. Okay, so red pen, area equals base times height. That's the formula. So now let's apply this. So area is what I'm trying to figure out, equals base, the base here. Well, where's our right angle? This doesn't make a right angle. That certainly doesn't make a right angle. Neither do these. So you really can't identify the base. At this point, we don't know if the base is 6 or if the base is 5. It's got to be one of them because it's going to be one of the sides, but we don't know yet. Well, since we're on grid paper, the easiest way to make a right angle would be to take my horizontal line here and to go vertically between the 2 horizontal sides. So if we do that, we'll have a right angle up there and a right angle down there. And then this is just 1, 2, 3 units right there. So now we can see that our base must be 6 units because that's where the right angle is with the 6 units. And then connecting those 2 bases is a height of 3 units. And so now, if we do what this says, 6 times 3 is 18. And then units times units, we don't have to write that in there at the beginning, but I do want you to write it for the end, just as a placeholder. And so units times units will be square units. Now later on, if we find out that these units are all in inches, so each of those little blocks is an inch long, then we would just replace this with square inches. If we later on find out that this is each unit is a centimeter, then this would just become 18 square centimeters. So we do put the units squared here for the answer, just as a placeholder. All right, well, let's take a look at another example then. Excuse me. So for our next example, we're going to skip a couple spaces, and then I want you to come down 1, 2, 3, 4 more spaces, make a little mark. So it's going to be a total of 6 down. But then what I'm going to have you do is I'm going to have you come back up 4 and then go right 3. Make a couple little marks there. And then I'll connect those. And again, I'm going to have you go out 6 spaces. 6 spaces there. 1, 2, 3, 4, 5, 6 there. And I'll connect the ends. So again, I know that's a 6 and that's a 6. Once again, using techniques that I haven't taught you yet, I can tell you that the 2 sides here are both 5 units long. So our formula is still A equals BH. Now to figure out what the base is, though, we need to have a right angle. Don't have that yet. So none of my sides make right angles, so I'm going to have to draw in something or measure something in. Here that makes a right angle. And this is 1, 2, 3, 4 spaces long. So notice that both of these parallelograms excuse me, have side lengths that are the same. They both have 6 units on 2 sides and 5 units on the other 2 sides. So they're going to have the same area, right? Well, let's do the math. The area of this guy, though, is going to be the base. The base, once again, is 6 units. Times the height, what makes the right angle? Oh, this time is 4. Well, 6 times 4 is not 18. 6 times 4 is 24. So this one actually is 24 square units. We should circle our answers. So, ladies and gentlemen, one of the things that I need you to see here from these 2 examples is that it actually doesn't matter what the side lengths are on a parallelogram. It matters what the base and the height is when we're finding the area. Okay. We're going to do one more. So this time we're going to drop down 2 spaces. And then I want you to drop down 1, 2, 3, 4, 5 spaces more. And then I'm actually going to have you come in 1 space and make a little mark. A little mark there. So that's going to be a total of 7 spaces down and then 1 in from that corner right there. 7 down, 1 in. All right, now I'm going to come back up and I'm actually draw the line 1, 2, 3, 4, 5 units long. Just draw it straight up, 5 units long. And then I'm going to go over 1, 2, 3, 4, 5, 6 units. 1, 2, 3, 4, 5, 6 units. And then I'm going to go straight down to connect those. So it should be pretty easy to see here that this is going to be a 6 and a 6 again. And it should be even more obvious that this is 5 and 5 now. So if we find the area equals base times height for parallelogram, this time I do have right angles. My 6's and my 5's are making right angles with each other. So this time 6 can still be my base, but since the 5 makes a right angle with the 6, the 5 is the height. 5 times 6, the area is 30 square units. So ladies and gentlemen, most important thing when you're finding an area of a parallelogram, make sure you find that right angle. It makes a difference. All these parallelograms have the same side lengths, but because of how they're tilted, they have different areas. And ladies and gentlemen, that's area. Now we're going to move on to the angles of a parallelogram. So the angles of a parallelogram, there's a few little properties here. So first of all, the adjacent angles are supplementary. Adjacent angles are supplementary. I'll put a period at the as a sentence. And supplementary is just a fancy way of saying if you take two of them and add them up, it's always going to be 180. So in this case, there are two, there's a couple things. I could go A and B, adjacent means next to. So if we just consider going around our parallelogram, A and B are next to each other. So this means that A plus B has to be 180 degrees. If I can continue around, B and C are next to each other. So B plus C must equal 180 degrees. C plus D must equal 180 degrees. And finally, D plus A must equal 180 degrees. So if you know one of the angles of a parallelogram, you should be able to find the two angles that are adjacent to it by using one of these equations. The other property here, the opposite angles are congruent. And congruent, remember, is just a fancy way of saying they have the same shape and same size. Well, in this case, congruent angles specifically, since angles are all about the shape, they're really going to have the same angle measures. So this means that opposite angles, so A is opposite of C, so A equals C. And B and D are opposite, so B equals D. So when you know one of those, you know it's buddy on the opposite side of the parallelogram. Another way of looking at this is, in a parallelogram, we have two acute angles and two obtuse angles. The two acute angles will have the same measure. The two obtuse angles will have the same measure. Of course, the exception to this would be if our parallelogram is also a rectangle. But if it's also a rectangle, then we just know all four angles are 90 degrees, they're right angles. Okay. So, last property here, the sum of the measures of the angles is, well, we can actually put this together using the properties that we've just talked about. So if A plus B is 180 degrees and C plus D is 180 degrees, then adding all of these up must be a 180 plus a 180. Well, that's a total of 360 degrees. So therefore, A plus B plus C plus D equals 360 degrees. So let's apply this now to this parallelogram here and find its missing three angle measures. So probably the easiest one to start with would be to use the opposite angles. So if I know 110 degrees is opposite of W, then I know that W equals 110 degrees. Ta-da! Done. That one's easy. Now for these other two guys, they are adjacent to the 110 degrees. So that means they're going to be supplementary. They will add up to 180 degrees. So I could say that x plus 180, oh, sorry, not 180, I'm getting ahead of myself. X plus 110 degrees equals 180 degrees. Do a quick little rearrange of this problem. Use your fact families. 180 degrees minus the 110 degrees then must be my x. Well, that's easy enough to solve. 180 minus 110 is just going to be 70 degrees. So now, sometimes it helps if you actually draw this in your homework, and then as you start figuring things out, start writing them in. So I know that this is 110 degrees. I now know that this is 70 degrees. Well, x is opposite of y. That's going to be the easiest way to finish this off. Since these guys are opposite of each other, I know that y equals x. Whatever x is equal to, y is equal to that. Well, we just figured out that x is 70 degrees, so therefore y must also be 70 degrees. And if you do a quick little double check on that, all four of those should add up to 360 degrees. So 110 plus 110 is 220. 70 plus 70 is 140. 210 plus 140, sure enough, is 360 degrees. And that, ladies and gentlemen, is our lesson.